Welcome to your own channel of Right Funda. Here is another interesting question from rotation mechanics. There is a problem of hinged rods. Let's read the question. Two identical rods of mass capital M and length small l are hinged together as shown in the figure and lies at rest on a smooth horizontal plane. A force capital F acts on the rod at the end A of the rod OA. Calculate the instantaneous acceleration of the hinge O. There is a hinge point there. We need to calculate the instantaneous acceleration of this point O point. So a force act, as soon as you apply the force, at that time we have to find the acceleration of point hinge point O. So if you wish, you can pause the video. You can try solving this problem. After that, again you can resume the video and you can match the answers, seeing the solutions. Now let's discuss the question. What is happening here? So you apply some force here. So this is not a continuous rod. This is not a one rigid rod. It is a made up of two rods, and they have hinged at this point. O point, they have been hinged. So can we take hole edge system? And what is the disadvantage of taking the hole edge system? Because here there will be some force will be there, and the rod will not be rigid. The angle between the two rods will be keep on changing. So we have to draw the free body diagram of the rod. So when you want to draw the free body diagram of the rod, there will be force F is there. Here there will be an hinge reaction will be acting, and hinge reaction will be internal forces. But every rod I will be drawing, then there will be some hinge reaction Rx Ry will be there here. Rx Ry will be there. So let's draw the free body diagram of each individual part separately. So if I take this is my system, and if I see this one is that force, this rod is there, and this force F is acting on this rod. Okay, so if I take the lower part of the rod will take, then here Rx I've taken the left hand side, suppose, and this is an Ry in the downward direction, and every action is equal and opposite reaction. Ry and Rx will be there, and let this acceleration of this point be equal to A1, center of mass of this point. Then give the name C1 and give the name C2, center of mass of the second rod, and this is equal to A2. Also that will have some alpha, we don't know which direction will be there. Let's assume that it will have tendency like this, alpha 1, and this also has a same, we don't know, it may be opposite also, but is equal to alpha 2, for example. Here is same here like this. In case Rx in the rightward side, it will be like this. If here F is greater than Rx, it will be like this, and in this direction is there, but we don't know. So what can be done? This is once we have written the equation, we can write the equation of motions for this. For the first rod and second rod, we can write the equations of motion. So what equation of motion we can write in the first rod? You will see that first equation we can write F minus Rx equal to M A1. That's correct. Because net force equal to F minus Rx in this rod, and right force, only one force is there. Rx is equal to mass of the second rod into acceleration of center of mass of the second rod. And we have taken this mass of both the rods are same. Question is given, so we can the Rx is equal to M8. There are two equations we got, equation number 1 and equation number 2. Two equations we got. Okay, again we can write the torque equation for both the things. So here on this you see the F also producing clockwise torque and Rx also producing clockwise torque. And here you will see the only one force is the Rx is producing clockwise torque, and alpha 1, alpha 2 also I have taken clockwise. So if I take clockwise as positive, in the first rod who will be producing alpha is that L by 2 into F plus L by 2 into Rx is equal to moment of inertia of the rod about the center of mass of the first rod into alpha 1. What have we taken? We have taken this one force, this F into L by 2, about this point I am taking torque. So L by 2 into F plus L by 2 into Rx, both are clockwise, into moment of inertia of this particular mass of this rod into L square by 12. Similarly, second rod also we can write the equations for the second rod, and second rod we write the torque equation, right? Then L by 2 into Rx is equal to ml square by 12 into alpha 2. These are two equations we written, and from this we can write acceleration of point 1. What is the acceleration of hinge point will be there? Once we know the hinge point acceleration, but kinematics we know that hinge point acceleration, this point acceleration will be equal to is a hinge point, H point, I have given the name hinge point is there. Acceleration of hinge point with respect to ground can be written acceleration of hinge point with respect to C1 plus acceleration C1 with respect to ground. Similarly, we can write also acceleration of hinge point with respect to ground can also be written as the acceleration of hinge point with respect to sit2 plus acceleration of sit2 with respect to ground. Can be written, both can be written. Okay. So if I write the first equations, I'll write, then I got this is equal to minus L by 2 alpha 1 plus A1, because hinge point acceleration when alpha 2 for the rotation motion, it will be one acceleration will be getting like the tangential acceleration, and A1 is going with the A1 acceleration, C1 is going with the A1 acceleration, and alpha 2 into L by 2 into alpha 1 will be there. So I want to write from this also, I can write hinge point with respect to ground. Now for the hinge point, we going to go L by 2 into alpha 2 plus A2, because right now both are in the I cap directions will be there. Whereas for this point, I will see this will be going like this. So this point has a tendency like this, and A2 also like this. Both are added together, but here A1 in this direction and alpha L by 2 into alpha 1 is in the backward directions or leftward direction. So these two are there. So whether you calculate the hinge point by this way or in this way, both hinge point is the only one point is there, that has to be same. So if I equate both the things, hinge points acceleration calculated by both the methods from rod 1 and rod 2, I can write like this, both I written, and I can simplify A1 plus A2 or A1 minus A2. If I take the A2 to that side, I got these equations. So let's call this equation as equation number 3. Okay. Now similarly, if I see this one, and from this I can write A1 ka value I will substitute from these equations. What is the A1 value? A1 I can get from this value is equal to F minus Rx by M, and A2 is equal to Rx by M, or I can add both the equations, and A1 plus A2 I can calculate. A1 plus A2 I want to see, A1 plus A2 is equal to what? This will be cancelled, and F by M. A1 plus A2 can be written F by M. So if I write from this, I can get the alpha 1 from this, alpha 2 from this. If I take to this side, I can alpha 1, alpha 2, everything, A1, A2, I can get from this equation. I can substitute there, or if I see anything can be simplified further. So one thing I require the A1 minus A2 I require, and I got the alpha 1 plus alpha 2 I require. So if I see A1 minus A2 from these equations, I will subtract this one, then I got the A1 minus A2, this will be cancelled, and I got F by M. A1 minus A2 is equal to F by M. And from this alpha 1 plus alpha 2, I'll say that this will go to this side, this two will be cancelled out. If I, sorry, this alpha 1 plus alpha 2, this will be added together, and alpha 2 taken common. So F plus 2Rx, F plus 2Rx, and 12 by ml square will go to the left hand side. So this thing I can substitute here, and if I substitute, I get the values like this. A1 minus A2 I substitute, alpha 1 plus alpha 2 from equation number 1 and 2 I substitute, and simplify this one, because this I'll square by 2 and 3 terms are there. 3 gone to this side, 3f into 2 into 3 is equal to 6. And simplify this, I can get the value of Rx, 8Rx equal to 2f, and Rx is equal to minus f by 4. So what we have taken, Rx is equal to whatever directions we have taken, is it will be in the exactly opposite direction to that will be there we have calculated. How? Because this comes with minus sign. So Rx, I have taken the direction, it will not be acting in that direction. F by 4 is acting. So I have taken Rx like this, not act like this, it will be acting like this here, and on the other rod it will be in the backward direction there, because I don't know initially, so I have taken Rx, but it came out to be F by 4. Now once I got the Rx value from this equation, I can calculate the A2 value, A1, A2 I can calculate. So I can get the A2 is equal to Rx equal to minus F by 4 minus F by 4, and this M gone to this one. So this will be F by 4 by M. So I calculated A2 is equal to minus 4 F by 4M.
And from this we can calculate the value of alpha 2 can be calculated. And how to calculate alpha 2? If I put the value of Rx to be equal to minus F by 4 that we calculated, if we put this one, this will equal to minus 3 by 2 F by ML. This we obtain the two results we obtain, one for the A2 and for the alpha 2. Once we got the A2 and alpha 2, then we can easily calculate the values of the hinge point acceleration can be calculated. We can calculate here, we see, suppose you this is the hinge point acceleration, hinge point is equal to this plus this. I have taken the forward direction of positive. So if I substitute the alpha 2 value and A2 value, I could have got from this also, because as hinge point acceleration can be calculated from here. If I calculate A1 and alpha 1, I could have got this one. But as I have calculated here A2 and alpha 2, these two, because two equation and this equation 1 say I could have got a1 also. If I substitute these values, then I can get L by 2, alpha 2 is equal to minus 3 by 2 F by ml, and A2 we have obtained here minus F by 4m plus minus F by 4m. So this comes out to equal to minus F by m. So what you got, acceleration at hinge point with respect to ground is this. This can be written as also F by m, that minus I cap direction. So what you got, as soon as the collision, the hinge point will accelerate in the backward directions. The striking, particularly striking, and we obtain the acceleration of hinge point. The question what is asking, calculate the acceleration of hinge point, that we obtain to be equal to F by m in the backward directions. We obtain this one
because they are hinge rods where they are taken separately, and we have calculated this one. So now the question people may be thinking that why this acceleration of this point is F by m, why not F by 2m? Because m is there, this m mass is there. So if you take whole as a system, you will get the ACM is equal to F by m plus m. Total mass of the system is equal to F by 2m I cap should be the answer by the whole system. But this is ACM, this is the ACM is there, and A center of mass and hinge point are not the same thing. Why? People may think these two rods are there, center of mass must be here and hinge point is also here. Yes, they are at the located at the same position at that instant, but that is not the true all the times. Initially they are coincidentally they are coinciding with each other. Coincidentally they are coinciding with each other. But this 2-point hinge point, and because after some time this rod may be like this also. Center mass will be reaching here. The two rods ka center mass will be here, and the hinge point will be going here. The acceleration of the center mass and acceleration of hinge point, they are two different things are there. The rod may be going like this also. The hinge point will go like this also. Acceleration may be like going like this also. The rod may go like this. So the hinge point and the center of mass, at that instant they are just at that point, but they are not a two different things. What you will be getting, ACM will be equal to F by 2m, that is correct. But what question is saying the hinge point ka acceleration, because their velocity has to be different. How the velocity will be different? Because their acceleration has to be different. We'll be solving another problem where we'll be taking the velocity. In the next video, we'll be discussing about the velocity of the rod, velocity of center mass, or that will be discussing. It will be more clear to you in this case. So usually you want to get a center mass, you can get this one, but hinge point velocity, hinge point acceleration cannot be obtained from this one. They are two different points. So in case of hinge type of rod, hinge rod problem, you take separately both the parts, both the rigid parts has to be taken separately and to be solved, and you will be getting the right answer.